Good evening to you all. And as Heshan introduced, I currently work as a junior lecturer at the Department of Electronics and Telecommunication Engineering, University of Moratuwa. And within that time that I spent at Moratuwa as a student and as a junior lecturer, I have been working with, and I have been working together with my colleagues a lot on a number of research projects. And over the years, when you work in research and engineering projects, you start to get a hang of it and like start seeing certain patterns that you can use and reuse in the future projects. So thank you very much for facilitating this small session for us to discuss some of those best practices, some tips, and some points of motivation that me and my colleagues have discovered over the years after doing a number of projects with the Department of Electronics and Telecommunication Engineering at University of Moratuwa. So this presentation is titled Landing an Impactful Research Project, a set of best practices, tips, and points of motivation. And I should give a little warning about the content here. So it's mainly focused on the final year students who would be doing their final year projects this year. And but still, there would be certain elements that would be quite useful for junior students from year 1, year 2, year 3 as well. And since I'm familiar with some computer science topics, such as machine learning and signal processing, I would be making some references to explain or sort of emphasize my points. So I hope that's okay. If you can't follow them, let me know in the chat so that I can use more insightful explanations. Right, so with that, we can start our presentation. So we'll be looking at what is a research project. And then we will be looking at the stages of a research project and how you can successfully journey through them. And then we will be talking about some useful tools and some tips. And then I'll be sharing a bit about my story as a final year undergraduate doing our final research project. Maybe you can get some insights from that. And also I'll share some final summarizing thoughts that would summarize this session. And then it will be up to you to ask questions if you have any. So what is a research project? So you have been learning a lot of important theories and concepts and principles in the last few years. And if you are a first year student, you will be doing that in the next couple of years. It will be a fun journey. And it will be difficult, but it will be quite illuminating and enlightening. And these concepts would be distributed in a wide array of areas, such as mathematics, computer science, electronics, telecommunications, and biomedical engineering as well. So among these areas, there are a lot of opportunities to pursue a lot of projects, which are either can be pure theoretical or application oriented or hybrid natured. So theoretical projects usually involve developing some theoretical basis or some theoretical approach to a general class of problems. For example, if I take an image segmentation algorithm, so if you are going to develop an image segmentation algorithm for a wider class of applications, then that would be a theoretical project because you will be addressing a lot of problems through it rather than a single problem. And then you have application-oriented projects where you focus on a certain application. For example, you can think about segmenting brain tumors. So that's a very focused area. And then you can work on that problem and then integrate some domain-specific information or some application-specific details into your algorithm or your method. And then you have hybrid nature problems where you sort of work with a bit of both, where you try to develop some theory and also at the same time apply that theory into a small class of problems that are similar natured. So these are the three broad categories of projects that I have been seeing, and I think they sort of explain the taxonomy of these projects, and also in the fields that I mentioned earlier that you have been learning or you will learn in the future, there are a lot of problems that are unsolved in these fields. And so it's an exciting time to be in the 21st century because a lot of things are happening and there's a lot of ways for us students to engage in them to help broaden our understanding on these topics. So then then we can formally define what research project is. So it is basically a commitment where you select a field that you are passionate about. That is very important because you will be working on a project that for some time, and then you should make sure that it's in an area that you are very passionate about. Because like Steve Jobs said, love what you do and do what you love. So it's a simple algorithm. And then you should formally define a problem involving those fields that you are passionate about. And also you should agree upon a set of objectives to complete within that project duration. And then most importantly, you should work towards those objectives within a limited period of time. So this is where we can formally introduce what research project is. And thereafter, it's very important to see what sort of motivations that we should have before we start a project. So the motivation, as I see it, of starting research project primarily should be to solve a pressing problem or an important problem in a field that you are passionate about. And also it should be with the intent of improving our understanding of that field. So you are going to be scientists, you are going to be researchers. So therefore you should have a motivation towards contributing to the larger picture as much as you can. And therefore, at the same time, I would like to highlight that it's not just, I mean, the motivation should purely come from the above two factors that I mentioned, but some people, they also find other motivations, such as getting credits on academic transcripts, which is important, I would say. And then winning awards at popular competitions, which is also important, and also publishing research articles. So these are satisfactory or justifiable motivations that could kickstart a project. But still, I believe if you your motivations would be pure if you are doing a project just because you are passionate about the field and solving the problem that you are working with. And if you do a good job, then obviously the credits and the awards and the articles, research articles, would automatically follow. So that's the principle that I would like to give at the very beginning of this session. And then what sort of pros or advantages do you get when you work on a strong research project? So I can think of 3 reasons. First, it will certainly help you expand your knowledge in the areas that you will be working with. And also it would add color to your profile, your curriculum vitae, and also it would really help you when you apply for higher studies and job opportunities. And I have very good experience of that, because when we were applying for our PhD programs, they heavily ask about what sort of projects you have done and how well you have applied the content that you have learned in the university into a real world problem. And then it would certainly have a positive impact on your career path to become a researcher in making. So those are very important. And then I should also mention, since I anticipate a large number of students from ENTC being here, and some of them might be final year students, and it's fine. And then this message is for the students who are in semesters 2 to semester 5, because they have a nice opportunity given by the department where they can involve in a self-initiated project during the semesters 2 and 6. And then if that works out well, then they can claim some credits for it by showcasing that project before a panel of lecturers, so that they will evaluate it and give you some credits. So be sure to have that opportunity. And also for the final students, there's a nice module called Research Project Module in the last year, which is open for ETC students. So it'll be great to get opportunity to go through that and then do some research with a faculty member, and it will certainly help your prospects of getting into research in the future. Right, so then before we move on to the next stage, I would like to emphasize a quote that I have been keeping very close to my heart, which is always strive for excellence before you chase success. So this was told to me by one of my mentors when I was starting my university life back in 2016. And I think it's one of the most impactful quotes I have heard in my life, because it gives you the meaning that the success would automatically follow if you strive for excellence. So if you keep focused on the quality of your work, the dedication, the commitment that you give to that, then obviously you will, the success that you desire would follow automatically. You don't have to explicitly follow it. So with that, we'll have a look at some stages or important stages of research projects. So I should again note some of these stages are based on my experience at the University of Moratuwa, and there might be certain differences between how other universities perceive projects. So therefore, it's better to consult your institution when you finally get to do your final year project or any other project. But still, I think you will be able to adopt some of these steps for your projects, and especially for the junior students, you will be able to get some guidance for the self-initiated projects that you will be engaging in the next couple of years from this session too. So first, most important stage of one of the most important stages of a project is to form a group that can work well with each other. So therefore, I would like to recommend it's better to get together with a few colleagues who you are friends with, and who have roughly the same interests as you, and also they can check whether they can bring multiple skills to a project. It's fine if they are still learning, because almost all the projects have big learning curves, and therefore skills can be learned during the projects as well. And then again, importantly, they should have a sense of responsibility and commitment, because that's one of the most important ingredients to a successful project. So these three factors can be considered when you are getting together with a few colleagues to work on a certain project. And then you can start forming a topic to start work with. So there are two approaches of forming a topic. So if you are if you want to propose your own topic and start working on on a field that you're passionate about, then maybe this method might be helpful for you to propose your own topic. So for that, I would advise you to, before that, I would advise you to select a few fields that you are really interested in, based on the things that you have learned in the class, and also based on the things that you have heard from seniors, from your lecturers, and from other sources of media, such as books, papers, or YouTube videos, blogs, etc. And then after you pick these fields, get familiar with the current trends and problems in those fields. So I'll be explaining how to keep yourself updated in the current trends of a given field later in the presentation. And then after you do that, so you can, I'll give a brief recap of how you can get familiar or updated with these current trends. That's one thing that you can do, is to read research articles, patents, reports, and blogs, etc. And also you can attend conferences, forums, workshops, either globally or locally. And especially these days, because of the COVID-19 pandemic, a lot of global workshops and conferences are happening online. And therefore, and these conferences have very low entrance fees. So you can easily get into one and then see what sort of things are happening in this field currently. And you can talk to some people who are working in those areas. And then you can also talk to senior faculty members, PhD students, your senior students in the university, and also people from industry, to get an idea about what sort of current trends exist in problems that you are interested in. And then quickly analyze whether you can feasibly do this problem within the given time, resources, and the available supervision. Because sometimes there are areas that you have a big interest in, but however, because of the lack of faculty members, sometimes the supervision would not be given properly within this university. So therefore, sometimes it's better to factor in those conditions as well. So I believe you'll be able to do that once you get an idea about how the subsystem works. And then, so based on these insights that you have gotten, then you can form your topic to work on. So that's one way of proposing, that's basically one way of forming your topic. So next you can also go for the option of selecting a topic provided by the faculty members. So this is quite easy, and these topics are usually proposed by the faculty members after giving a lot of thought. And therefore, these problems might be feasible, so you don't have to think about the supervision or the time or the resources that you would have, because they will be already available in the university. And then what you should do first is to go through the list of topics that the faculty members have given you, and also if there are descriptions, go through them thoroughly. And then after that, you can discuss with your team and shortlist some of the topics that you got interested in. And then you can meet with the faculty members who are proposing these topics of interest and have detailed discussions to confirm whether this is the right topic for you, and then run a quick assessment of topic's feasibility, just in case. And then finally, based on the insights you got, you can pick the topic that suits the most and then start working on it. So that's basically how you form a topic. And then after you come up with your topic, then you can start having initial discussions with your supervisors / collaborators. So here, be sure to meet the supervisor or reach out to a potential supervisor after you fix your topic. And here, the supervisor should not necessarily be from the department that you are in. It could be from some other department, or you can have a co-supervisor that specializes in a field that is involved in this project from another university, from another country, etc. And then you can have detailed discussions with them about the topic and think about making minor amends or adjustments to the topic if needed to make it more suited for the course requirements and also to your interests, because that is important. And then discuss about the potential co-supervisors and external collaborators from other departments, universities, or countries, because sometimes the faculty members in our universities, they have colleagues who are working abroad, and sometimes it will be best, it might be better to take some guidance from these supervisors who are abroad, because they have a different exposure than here, so therefore they can bring a lot to the table as well. So do think about that aspect as well when you have these discussions, initial discussions with your supervisors. Yes, and then we come to the feasibility study, which is also an important step in your project. And sometimes in most universities, I think this stage is getting evaluated. I know in Moratuwa, they do that. So they ask the students to run this feasibility study and then produce a report or presentation, and then that would be evaluated by a panel of lecturers to assess the feasibility of this study. So generally, from my experience in a feasibility study, you should conduct a comprehensive literature survey. So we will be looking into these subtopics later in the slides and going through how you can successfully conduct a literature survey. And then you can define the scope and objectives of the project, which is also important, because scope and objectives are something that you should have from the very beginning of your work. And then you can agree with your team upon the division of the work. It is also important, because people should take responsibility for certain sections of the project, and how to divide it, that is important in the very beginning. And then students have to prepare a detailed timeline or a plan of the project, because I'm not sure whether you have heard this small quote. We are planning to fail. Failing to plan is planning to fail. So that's an important thing to remember, because planning is quite important for a project of this caliber. And then you should prepare a rough budget for your project if applicable. Sometimes you would be spending some finances in certain risks to procure some resources. So therefore, it's important to prepare a budget as well. So because sometimes you will have to apply for grants and things like that. And then we'll start looking at the literature survey, which is basically about reading as much as research papers, technical articles, reports, patents, and blogs that are relevant to your research. So this is the stage where you get to know the problem and you get to know the sort of background details surrounding your project, so that you can get a very broad understanding of the topics and how you can approach this problem and what are the existing methods in this problem before you formally start your research. So, and also one of the most important elements that you can actually read during this period is something called review papers. You might have heard of it already. So review papers are basically a long paper, a large paper that summarizes almost all the seminal works within a given area of study. So basically it contains a lot of summaries about other methods which has been there for some time in a given area. And then after you read review paper, you get a very broad understanding about subject that you will be dealing with. For example, if you think about, like I said in the earlier stage, image segmentation. So you can, if you are working in image segmentation problem, then if you find review paper which covers the topic of image segmentation, then you would see all the algorithms such as watershed algorithms, anisotropic diffusion, and then deep learning methods such as MaskR, CNN, YOLO, and things like that. So then you can, after reading all of these diverse areas and diverse sources of information, then you can summarize the findings that you made from the literature survey. And so this summary is quite important because you can revisit this summary when you commence the implementations and experiments later in your project. And therefore, it's very important because you have, once you go through these research papers, you begin to understand what sort of techniques that are used by these people, the previous researchers, to solve this problem. And then while you do that, you may identify certain shortcomings of these methods and certain improvements that you can make to overcome these shortcomings. So therefore, it's a very important step, take it very seriously. And let's also see how you can take some help from some tools to improve the prospects of your literature survey, literature review as well. So most of you might know by now, Google Scholar is an extremely useful website for the feasibility study. So we'll be talking about this later in the presentation again. And this is sort of like a search engine where you can search for papers all around the world, published in many publications, so that you can access them at your fingertips from your computer. And then as you find your papers that are related to your project, then you can organize them properly so that you can revisit those when needed later. So obviously you'll have to revisit those papers and reread them again to get a better understanding. And then in similar situations, there are certain classes of softwares called paper management softwares, such as Mendeley, Sotero, Paperpile. So these are quite important and quite useful to organize your library of papers, and then later it will be useful for putting references to. So we will be talking about these softwares later in the presentations more. And then we come to the next step of the feasibility study, which is to define the scope and the objectives. And this is another critical step in your project, because scope is actually the extent to which you hope to conduct your project. So therefore, as you can see, it gives a sense of boundary to your project or to your research, so that you would be limited within a certain area or region of the problem that you are working with. So this is very important because sometimes most of the time you have a given time constraint to work on. So therefore, it's very important to define the boundaries that you would be within the time frame, so that you can successfully complete the project without any troubles. And also, it's very important to know, if you're doing a project, when to stop. So therefore, this stopping criteria can be actually taken from the scope of your project. And then you have the objectives, which are actually the critical or major milestones that you would be accomplishing in your project to ensure its successful completion. So objectives are equally important because they sort of give you a sense of aim or goals to achieve during your project. So therefore, getting the objectives right in the beginning is quite important. And these should be decided with the guidance. So the scope and objectives should be decided with the guidance of your supervisor. This is very important because in important steps like this, you have to always consult a supervisor and be mindful about the course requirements when dealing about the scope and objective. Because sometimes in the panel of lecturers might not take a certain scope as viable or fitting to the course requirements. So therefore, you have to be mindful and take some help from the senior faculty members to define your scope. So so these are like kind of like formal methods which are used in FIPs and final year projects especially. So if the junior students are there, they don't have to go through each and every step like this, but still they can, if they can adhere to some of these principles, then their research will be well defined and could be easy to follow. And especially for junior students, don't be afraid to reach out to supervisors, to us actually, because sometimes we might have certain ideas in mind which we can't implement due to the busyness of our lives, but we will be happy to give some of those topics for you to explore, and then we can supervise you in the meantime too. So a lot of faculty members are willing to do that. So therefore, don't hesitate to contact them, drop them an email, and start up a small dialogue to kickstart your project. So that will be quite important, and you will see how much of an impact that it would have later in your lives. So to give you a little example about this scope and objectives, I'll talk about my final year project, which was to design a cost-effective surface electromicroresonance system for a bionic hand. So basically, it was to get some signals from your hand and then use the signals to control a bionic hand in a very general sense. So we defined our scope as two components. So one component was to develop the software part of it. So to develop the algorithms, develop the pattern recognition algorithms and data handling algorithms and scripts like things like that. So the programming aspect of the project. So that was one scope item. And then the other scope item was the hardware component, which is to develop the sensors, the circuitry, and the PCBs, things like that. So that was our broader scope. So we limited ourselves within those two regions. And then our objectives was to develop a real-time hand-measured algorithm using the electromagnetic signals. And then we wanted to find a rule to optimally place our electrodes. And then we wanted to finish our sensor design, which was a major part of our project. And also finally to come up with the integrated sensor system, PCB, and the testing requirements of that. So these were the 4 objectives that we had placed in our initial discussions of our project. And then we can move on to the division of work, which is also very important. And so after this would usually happen after you decide the scope and the objectives of the project. So after you do that, you can then identify the independent elements of the project that can be implemented in parallel. So for example, the project that I just mentioned, the one that we worked on, it had a hardware component and a software component. So these 2 components were not related to each other at the beginning. So therefore, 2 of us worked with the software component while the other 2 worked on the hardware component. So the project was actually, the group was four-member group. It was a 4-member group. So me and another colleague work on the software component and the other 2 work with the hardware component. So then that way you can sort of expedite or accelerate the work. And then at the end, you can join the 2 components together to integrate them and then finally complete your project. So when considering this division of work, always think about the interest and the already acquired skills and the potential size of the workload of the element. When you think about these factors, when you deliver the work among the students, because some students might be interested in working with algorithms, so therefore give the algorithmic part to them, and some students might be interested in designing PCBs and soldering and things like that, so give that part to them. So like that. So you can divide the elements well if you identify what sort of interests, skills, and the ability to handle workload of that student. And then, like I said earlier, if you work with these independent elements parallelly, then later on you can join them, you can integrate them later on. And this integration can be achieved collectively, because then this integration should take place with the knowledge of both the groups of students, right? And then you can collectively integrate that well with the support of the group members. And sometimes it's important to notice that you have to reevaluate and revise the decision of work, because sometimes the scope and the objectives can change during the project span. So that happens. So this happens because of time constraints, resource constraints, and our unavoidable issues like the pandemic that you are facing at the moment, because things are changing these days. So you really can't sometimes foresee what will happen in the future. So therefore, it's better to keep a flexible eye to in a situation where you have to reevaluate and revise your plans. It's completely fine. And I'm sure your universities and your lecturers would understand that. And then always remember, you are a part of a team, and therefore the team expects the best out of you. And therefore it's very important and very critical that you do your assigned part completely and neatly. And then we have the timeline, because timeline is something that we request from our students to in the beginning of their project, so that they can sort of have a sense of idea of how they would progress throughout the given time when they do their project. So therefore, this timeline can be created using a Gantt chart. So this chart is called a Gantt chart. So this Gantt chart can be used to break down your tasks, and then so you can have to identify different tasks and then list them down like this, and then you can basically represent how when they should begin and when they should be completed, and also how long it would take this task to be completed. So these things can be represented at once using a Gantt chart like that. So be sure to work on a plan like this, because planning is always a good thing, and then because it keeps you on check every time and every level of the project. And then you have the feasibility study element, budget. So some projects, like I said, would include the financial aspect to it. So therefore, it is recommended to prepare a list of items and services that you would be requiring throughout the project alongside with their respective costs. Because, for example, if you are working on electronics or hardware project, then you have to buy certain electronic components, right? And therefore, and sometimes you have to buy PCBs. You have to get the PCB fabrication services. So therefore, these things need costs and finances, and therefore plan them ahead so that you can meet them when you need to acquire those services and items. And this budget would help you plan the financial requirements of the project and then how to fund them. And sometimes these funding can come from different sources such as university grants, organizational research funds, and government research funds. So be sure to contact your supervisor about funding options, because he will surely know what sort of funding is available for your project. And then we come to probably the most important step in the project, which I call eat, implement, experiment, document, sleep, and reiterate. It's a bit of an involved cycle, but still it's quite important, because these elements of this cycle are exactly what you should be doing and try to follow during the project. So the first one is, I would take implement. So after you do the literature survey, you have a basic broad understanding about the area that you are working on. So therefore, you can start implementing the methods that you have found in the literature review. And it's very important to start with the simplest approach. This is very important. And then you start with the simplest approach and then move towards complex approaches. So this comes from a principle called Occam's razor, which states that the simpler the method, the more elegant it is. So therefore, try to always look for the simplest method rather than going into heavyweight options. So therefore, try to keep this in mind, and this would surely pay off, and it will result, and it will help you gravitate towards a very simple but elegant solution to your problem. And then you have the experimenting stage. So after you implement a method, then you have to design experiment to verify their validity and their applicability to your problem. So this is very important and critical, because once you design a method, you have to think about how to evaluate that and what sort of results it could give. So therefore, you have to design very standard and neat experiments to conduct that validity survey. So these experimental steps might include collecting data according to a standard protocol. So biomedical students might require this at some point. And then defining appropriate performance metrics is important to evaluate what sort of performance is given by each method to the same experiment. And then sometimes you have to construct experimental setups as well. So this is actually important because, like I said, sometimes you have to collect data, and sometimes if the data is either from human or animal data, you have to get the ethics approval from certain authorities. And then so you have to be mindful about that and talk with your supervisor to get some idea about designing experiments well. And then you have to document your work, because as you make these implementations and experiments, and then when you get outcomes, then you have to write them down. You have to record them, because later on you will have to revisit them. And when if you are getting to write a paper out of that and report out of that, then it's very important to remind yourself about the work that you have done. So therefore, it's very important to document. And for this purpose, you can use tools like Microsoft Excel, OneNote, and GitHub, etc. So we'll be talking about them later in the presentation. And then reiterate. So now you have completed implementing, experimenting, and documenting, right? So after that, you can reiterate these steps, because you will be implementing method after method, and then realizing what sort of issues they have, and what sort of new ideas that you can implement to improve these methods. And sometimes, better yet, you would have also gotten new insights and new intuitions to propose your own method that would be highly beneficial and highly encouraged to do, because that would result in new discoveries, right? And therefore, this is the key steps that you have to follow. And then last but not least, we have eating and sleeping, which is basically trying to keep yourself healthy and fit, and also take breaks when things get a bit hectic and stressed. So it's very, very important that you take breaks and engage in some free time activities that you enjoy outside of your work, so that you can keep yourself refreshed and have clarity, because that clarity is very important when you think about these complex problems and trying to figure out a solution for that. And also it will help you strengthen your bonds with your group mates, which is also equally critical. And then you have progress reviews, which is to meet your supervisors and co-supervisors and external collaborators at least once a week or once in 2 weeks. So there, when you go and meet your supervisors, make sure that you prepare a few slides, including the updates of your work that you have been doing during the week, so that they can get an idea of the sort of work that you are doing at the moment. And therefore, and also during these sessions, you would be talking with them, and the experience and insights would be very beneficial for your work, and you can learn a lot from the supervisors. And speaking from my experience, I learned a lot from my supervisor, and these inputs that they are giving would not only be useful for your current project, but also it will be making an everlasting impression on your entire research career in the years to come. So therefore, it's very important that you maintain a good relationship with the supervisors and co-supervisors. And then these are the boring parts, because you have to present your work to a panel of senior lecturers to get some marks. And so that's why mid and final evaluations are there. So the way to get through these are to plan ahead, like I said earlier. So make your presentations well and rehearse them, and make sure to use the documented methods that you prepared earlier to prepare your lecture, prepare your slides, and also, if possible, make a demonstration video about your project and then put up and show that to the panel, and they would be impressed by it. And also, another thing that you can do is to anticipate the questions that the lecturers might ask, and then make some additional slides apart from the main slides to answer those questions if those are popped up. So that sort of shows you how well prepared you are for the evaluations, and that would create a good impression in the faculty members who are evaluating your project. And then this is a summary of the, actually this is the writing. So the last step is the writing the thesis part or writing your report. So basically this is where you compile all of the information from literature review, methods, experiments, results, discussion, and conclusion to result in a detailed technical report. So this is very important, and make sure that you follow the report or thesis format given by your department or institution when following this. And then this is the flow chart that you can think of when you think about the project. So I will skip through this quickly to move to the next slide, which is to talk about some useful tools. So first one is primarily for intended for coding projects, especially when you're working with a project involving Python, C++, Java, etc. So Microsoft Visual Code is a very nice platform for you to continue your work, organize your work in a project where you primarily work on programming. So, and also when talking about programming, be sure to learn some Python, because Python is highly useful, and it's a very flexible and very popular language in the current world. And there are a lot of libraries such as NumPy, SciPy, Matplotlib, Pandas, Seaborn, sklearn, TensorFlow, Keras, PyTorch, SKIMage, OpenCV. So these are like some libraries that you can find on the internet, and they are quite useful and can do a lot of tasks for your project when you are involved in them. And then you have Google Collaboratory, which is a very useful tool which came out recently, a product of Google. And it also allows you to work in an interactive Python programming environment, and where you can rapidly implement your ideas. So if you have the quick idea, then you have to, if you want to implement it quickly, then you can use this platform. And also the good thing about it is that it gives you high computational resources that are used for high computational demanding projects, such as machine learning algorithms, which involves very high computational requirements. And to do that, they provide GPUs and TPU support access to the users. And also you can, this is like some of the course that I have been working on through Colab. So you can write tutorials and certain sort of like reports through it too. So it's a very useful environment where you can do both. And also it's very important for if you're a student who's willing to come into machine learning or signal processing or programming or scientific programming area, then co-laboratory is a nice place to start your work in. Actually, we are using that for our students in semester 2 to conduct some of their practicals in single systems. And then you have MATLAB, which is a very versatile and multimodal tool which supports many tasks across multiple domains such as signal processing, telecommunications, physics, electronics, machine learning, and mathematics. So you can use this very nice interface, very nice software to get your work done. It's a very easy programming language to learn, and a lot of courses are available, so you can take a look at them when you do your research. And then GitHub, one of the most profusely used platforms in the internet for version controlling and collaborating and working together in a software engineering / coding project. And also, one of the best things about this tool is that a lot of researchers provide source codes for their methods via GitHub, and then you can go through them and also keep track of your projects, and also finally release your projects, your source codes for other people to use later on after you complete the project. So therefore, it's a very important tool. So these are like some of the projects that I have showcased in that I have done and showcased in GitHub. It's a very useful tool. You can use that to organize your project as well. And then you have a ton of documentations and forums in the internet where you can solve your problem, because sometimes, almost all of the time, when you go through a project, you hit a certain obstacles, right? And therefore you have to find solutions to them. And these forums and documentations provide nice ways of getting your problems resolved, especially if it's related to coding or mathematics or etc. And then another important tool that is available in the MIT University is MIT Missing Semester, which is basically a set of courses that lets you get familiar about commonly used tools and techniques in computer science and programming. So these are like, they'll be useful when you go through a project. So make sure that if you have time to go through, make sure that you go through this missing semester as well. And then I would skip through this quickly. So if you are working with the electronics related project, especially in FPGA, there are development boards that you can use, and then microcontrollers and their programmers as well. So these are quite important in rapidly implementing your ideas and your devices quickly and simulate them. And then the next set of softwares are quite important when you are preparing your reports and your papers. So graph practicism is something that I use very often to conduct statistical analysis on our data. So because statistical analysis is a very important part in a project, because sometimes you have to compare certain two entities and maybe fit a regression line to a set of data. So therefore, to do those things, this is a very nice and interactive tool that you can use, and it also generates very professional, very nice graphs to be featured on your paper as well. And then R is also another similar software. I haven't used it much, but it still can do a fantastic job in creating statistical analysis and creating figures. So, and then you have Overleaf, which is probably one of the useful tools, mostly useful tools used by researchers all around the world, because that's an environment where you can write reports in LaTeX very easily, and multiple users can edit the same document as well. So therefore, collaborating becomes very easy through an Overleaf document. So make sure that you use that when you write a research paper or your report in LaTeX. And there are other methods like TechMaker that runs in local machines as well. But I think since this is an online tool, it's very easy to use it. So make sure that you use it when you write your reports. And then to generate figures again, you can use Adobe Illustrator. It's very cool software to make your figures and posters. So this is one of the posters that we made recently, which we presented. And then there's another very nice tool called IEEE, which is an open source tool for preparing mathematical figures, because sometimes you have to have certain mathematical expressions within your figures in LaTeX. So therefore, this IEEE tool is a very useful open source platform to do those things. And then we can take a look at Slack, which is a platform that I use very frequently to discuss about projects. And so basically, I would usually create a Slack channel or a Slack group for with a couple of colleagues that I'll be working with, and then I'll be using that to communicate with them regarding the experiments, methods, and also the papers that we find through our literature survey. And also we can send some code paths as well. It supports that, and then they can take a look at the codes and debug them. So these things are all possible in Slack. It's a very nice tool to use if you are involved in a project, and you see how easy it is to manage and organize different aspects of the project when you have a software like this to communicate with. And then, like I mentioned earlier, Mendeley is a reference management system. So when you do a literature survey, so you can add your papers into this software. So as you can see here, I have added these softwares, added these papers into this software. And then all of the papers that you are working with are under one roof. And then this actually makes the reference adding process in Microsoft Word or LaTeX become to be a very, very easy piece of cake because it helps you add references almost at no time. So therefore, I mean, working with the software is quite easy. I will be sharing these slides with you after the presentation, so then you can take a look at them again and then download the softwares and play around with them so that you can take a good look at how these softwares would be useful for your project. And then you have Canva, which is an optional tool that you can use for making presentations, such as your Viva presentations, because we used to make our presentations through that. So this is one of the several set of slides that we used for our final Viva. So the reason that we use this is that it supports nice infographics to make the presentation very much engaging. So therefore, this a nice tool to use in that sense. And then we talked about Google Scholar earlier. And then apart from Google Scholar, you have digital libraries such as IEEE Explore, Science Direct, Elsevier, and Archive, where you can find a lot of research papers for your study. So I'll give a little introduction about Archive. So it's basically an online paper repository where the authors can share their papers before they publish them in a journal or a conference. So this is done. So this is done because then they can quickly disseminate, quickly get their papers out. So if you write a paper and then the conference is like a couple of months ahead, then you can also put the paper into Archive and then see whether you get some comments from others and then improve it later on. So that's like a good use of Archive, and you can talk to your supervisor about it. And then many universities, including University of Moratuwa, provides free access to Microsoft Office 365. So this has some nice softwares. You already know this, Microsoft Excel and Microsoft OneNote. So these things can be used for digital note taking, and then they can be used to documenting your experimental details comprehensively. For example, this is a small format that I frequently use to keep records of my experiments. So I list down the experiment ID, the method, and some hyperparameters involving it, and also the performance metrics to compare the methods with each other. So that's basically that. So the next so that's basically some set of tools that you can use for your projects. And then we'll talk about some useful tips, and make sure that you understand that these are some general tips and you are free to adopt them to your project. And also it will be more better if you can make your own positive habits or rules while you engage in a project. So I'll quickly skim through these because we are running out of time at the moment. So let's have a look at how to keep yourselves updated about passionate research areas, like I mentioned very early in the presentation, how you can keep updated about latest trends in the topics that you are interested in. So the first one is to attend conferences and reading research articles as much as you can, which are in the same domain that you are interested in. So for machine learning, there are a nice set of conferences such as NeurIPS, CVPR, ICLR, ICML, TPAMI, etc. Signal processing, you have ICASP, ICIP, ISBI, etc. And then for electronics, you have conferences like ISCAS, and for robotics, you have ICRA, and for biomedical engineering, TBME, JBHI, EMBS, and Nature are quite important journals and conferences. And then for telecommunication engineering, you have very much interesting conferences such as ICC, Globecom, and WWW, which actually includes very latest technologies such as 6G and 5G and etc. So these are quite cutting edge technologies. So you can, if you attend them, as I said, these days, these conferences are like much cheaper to attend. So therefore you can try to attend them and then see what sort of new updates are going on with these areas. And then another nice way to keep yourself updated about these research areas is to listen to podcasts. So personally, I would like to listen to Lex Friedman's AI podcast, which is quite insightful. And he usually invites like a very popular figure from AI or machine learning or related field to come and have a chat with. And these conversations are like super interesting, and they like talk about like their future plans and sort of insights that they have, and they can be quite useful for people like us, people who are like coming to research very much. And then also reading blogs is a nice way of getting to know research updates. So towards data science in terms of machine learning is quite important in this aspect, and you can find a lot of other podcasts apart from machine learning ones in the internet as well. And then another way to keep yourself updated is to use your social media platforms effectively, because especially in platforms like Twitter, you have a lot of institutions, scientists, and labs who regularly make their updates available to their followers. So therefore, so here are some of the people and places that I have followed, which work in the areas that I am interested in. And then there are nice Facebook groups like AIDL, and Reddit subreddits as R machine learning. And also there's a nice channel in YouTube called 2 Minute Papers, which is quite insightful, and he explains like very complex papers in like in a simple manner. So you can take a look at that as well to keep yourself updated regularly in these domains. And then another important aspect that you can try out is to attend as much as research talks, tutorials, and workshops as much as you can, because there are like, and in these meetings you get to meet a lot of exciting people and often field leaders, and then you can ask questions that you have from them. And that's such a wonderful experience to have, because then you can interact with these great people who are doing great science. And then and that's always a good feeling to be as a junior researcher. So that's another thing that you can do. And also, last but not least, you can have access to a lot of online courses from platforms such as Coursera, edX, Udemy, Udacity, etc. And also, last but not least, MIT Open Coursera. These are like quite packed with a lot of courses in almost any field that you can imagine, and you can expand your learning curve through these platforms if you don't get a knowledge in the university in a fast manner. And then let's talk about some personal traits that you have when you are involving in a serious project. So I have listed down 3 traits. So first one is to become very curious and inquisitive about the things that you engage and things that you learn, and also become very flexible and adaptable, because you will face a lot of challenges during a project. That's the nature of projects. So therefore, you should be able to make compromises when needed, and that's why you should be flexible. And then you have to be teachable. That means that you have to be quickly learnable, or you have to quickly learn. You should have the ability to quickly learn from any source that is put in front of you. So therefore, these are quite important when you want to excel in a project. And then this is actually related to time management. So setting minor goals is something important. So earlier in the literature review, we talked about how you define the scope and objectives, and how you set major and critical goals of your project. And then to achieve these critical goals, you have to start by setting minor goals, small goals, which are like taking place weekly or monthly, and then engaging in them consistently and in a very much perseverant manner. Then you can sort of like take small baby steps towards achieving the higher target. And therefore, like I said, as you progress by achieving these minor goals, you will move closer to the final objectives steadily. So therefore, it's very important to set minor goals and achieve them, because that would be a rewarding experience. And then do not be afraid to step out of the comfort zone, because research and projects are all about taking risks. So do not be afraid to try absolutely insane and revolutionary ideas, and do not be afraid to go beyond the norms, go beyond the things that you are already familiar with. And also do not be afraid to follow your gut feeling, your intuitions, because sometimes they might be leading you to some important place. And do not be afraid to learn new things and expand your learning curve, because that's very important, because when you do a project, you have to learn a lot of areas. So therefore, do not hesitate to learn new things and step out of your comfort zone. And it's completely okay to make mistakes, because trial and error, and that's how science progresses. So that's all part of the plan. And then, of course, you might hit a few dead ends, few obstacles. It's fine. That happens to all of us. That happens to the best of us. So take a break, relax your mind, and take a step back. So that's how you manage these situations, right? And then think about why this approach went wrong. And then talk to your supervisors, talk to your group mates about it, have detailed discussions, brainstorm a bit, and then try to re-implement the method with these changes. And if it repeatedly fails, again, then move on. Then don't think about it. Label it as a failed method. So it was not a loss. If you discover the method like that, then you have discovered a method that you should avoid next time. So that's actually a discovery. So that's a loss, which is actually a gain. And then this is something that people often forget about, especially there are very studious students who are very good at technical aspects and logical skills, but they are sometimes a bit backward in soft skills. So I believe all the students should be concentrating a lot on soft skills such as communication skills, presentation skills, and management skills as well, because these skills help you communicate the specifics of the project to an audience, to a larger audience, and it's very important. It's as important as doing the project to communicate the ideas that you had to a bigger audience. So that's what science is all about. Creating something new and getting into the public or getting into the community. And then, like I mentioned earlier, competitions might be a small motivating factor for a project. So why not try for some of these competitions? So be on the lookout for competitions when you are in the middle stages of the project, because you might be getting some good results. Then you might feel that you would try your luck by entering a competition and then showcasing your work. And so a couple of benefits that I have seen over the years of participating in competitions is that sometimes it self-imposes a deadline for you to accelerate work, because you get a deadline for the competition and then you tend to work towards it. And then you can gain more public interest towards your work, because a lot of people will be participating in it, and then therefore you can interact with them and they might give you suggestions and so on and so on. And then also you can receive fresh insights from other parties, such as industry personnel, general public, and researchers, because sometimes like you are sort of blinded by your scope, and sometimes a person comes in and gives you a fresh idea, and then that might help you further improve the project. And then also these ventures might help you attract potential collaborators or investors if they want to invest in your project to make it a commercial product. That's also important for a country like us, which needs a strong industry to develop. And also you might, last but not least, receive some awards, cash prizes, or recognitions if you get lucky and if your project is top-notch. And then these are some competitions that I have dealt with recently and have heard. Of course, you have IEEE Signal Processing Cup, which University of Moratuwa recorded a historic win recently. And then we have IEEE Communication Society competition, ComSoc student competition, and then Myron Sucker undergraduate design competition by IEEE, and then you have APITCA, Innovate FPGA, and Microsoft Imagine Cup. So these are quite important global competitions that you can try out. And also there are some important local competitions as well, like SLAS Awards, NBQ. SLAS Awards is like one of the best awards there is to local FIP or final year projects. That's a nice award to try out for. And then you have NBQSA Awards, which are National ICT Awards. And then you have SLIOT and Brainstorm, organized by our chapter. And then we'll talk about how to transform your work into a potential research paper or a patent. So if your project goes well, and if you commit enough, then sometimes this project might surpass the performance of state-of-the-art methods in the problem domain. And sometimes it would be exploring a completely novel area that people have not researched about a lot in the past. So in these situations, then it might be possible for you to present your work in a reputed conference or a forum, or publish a research article in a reputed journal. So this is very important. And as you are taking like small steps towards becoming a researcher, having a paper at this stage would be highly beneficial. So let's talk further about it. So it is good to have a target to submit a paper from a project, but don't worry if things don't go as expected, because sometimes that can happen. It would depend on many factors. So don't worry if your expectations are not met. It's fine. You can always work on another project and get something done. And focus on instead of thinking about such expectations, focus purely on the quality of the methods, experiments, and arguments that you implement throughout the project. That's very important, because like I said, excellence before success. If you focus on excellent aspects of your project, then success would automatically follow. And then once you realize that your proposed method is resulting in good results, then directly consult with your supervisor to further improve the methods through his ideas as well. And then once you and supervisor feel confident about the methods and the experiments and the results that you have gotten, then you can select a suitable conference or a journal to submit your work. So when selecting these conferences or journals, then you can think about the metrics such as H-index or impact factor, which basically measure the quality of a publication or a conference or a journal. And then you should basically use websites such as Google Scholar Metrics or Cimego rankings to get these metrics to select an appropriate journal for your work. So then, yeah, so I would not explain how to write a paper at this stage, because some of you are like still very young and still barely getting into the projects. But if you are having good supervisor with you, then he would guide you step by step through the writing and submission process, because they are very proficient in writing research papers. And also the experience, like I said before, the experience of writing an impactful research paper, presenting it before an expert audience is a priceless opportunity that you can have as a young researcher. So remember that. And it's fine to work towards a goal like that, but don't be upset if it doesn't go as planned, because that happens, things like that happens. But you can always continue the project with a strong heart and then achieve that goal later on. And also make sure that you follow the ethical and best practices of writing a paper, and then it would be a more impactful and quality paper that you would have under your belt. And then always remember, if your university or funding agency is permitting the public use of codes, data, and resources of your project, then make sure to do that. Put them in GitHub, make a project website, and then advertise that project, then so that many people would gain visibility on the work that you have done. And also, if you do that, then all people all around the world can reproduce your results, and it would add credibility to your work, and that's very important. And then you can use social media such as Twitter, LinkedIn, Facebook to create more visibility for your papers and your patents if you publish any. So as we are nearing the end of our presentation, I'll thought of briefly going through our story as my FIP team underwent in the year of 2019. So our project was to design a cost-effective dry contact surface electromagnetic system for controlling a bionic hand. So as you know, we have been going through a very brutal war for almost 30 years in the past few decades. So there are a lot of people who don't have limbs, especially arms and legs. So our project was focused on providing a local solution to that problem. So our project was supervised by Dr. Simon Kappel and Dr. Tilna Alituratna from University of Moratuwa. Dr. Simon is in Denmark at the moment. So our team members were Kitmin, Asma, Marsha, and myself. So some of these members are actually working in the university at the moment, so you can meet them regularly. And some of the honors that we received at the end of our project was to have 2 publications in IEEE ICAS, which is the top conference in the world for signal processing, and also in ICAS, a paper in ICAS, in the paper in IEEE SMC 2020 as well. And we actually enlisted our project to IEEE ComSoc 2019 competition, where we were ranked among the top 15 in the world during that. And also at the end of the project, we won SLAS Merit Award for the best project in the country as well. So these are some of the snapshots from our project. And I wanted to put this image, which is something that I really cherish on the bottom of my heart, because this was the moment that we created the method that we finally went on to publish. So we kept a small whiteboard to plan our work and like write down some minor minor goals that we should complete by the end of this week or by the end of this month, next month. So things like that were written on this board, and it was like showing to all of us at all times. So like every team has its unique way of dealing things, planning things. So I would encourage you guys to find your own style to complete that. So this is our method, having a small whiteboard in our vicinity. So you can do something similar as well to get your project ongoing. So let me share some final thoughts out of this presentation. So first up is make the best out of the time you have. So these days, it's COVID, it's not a great time, it's true. We can't go out much, we can't hang out with our loved ones much, but still, this COVID-19 lockdowns are actually a blessing in terms of project, because you can learn a lot and can do a lot of self-learning, you can do a lot of individual work during these days, and then expand your learning curve to do some impactful projects. And also keep the spark that you had at the beginning of the project alive throughout the entire project span. That's how you make this a reality. And like I said earlier, be very curious, flexible, and adaptable, and very teachable during the span of your project. And don't be afraid to try new things and new revolutionary ideas that you are passionate about and that you have and that you think that might lead to a nice solution. And then try to work on the same specific space or lab as much as you can, because that can sort of generate new ideas and pool new ideas among the group members, so that it would help you move forward as a team. These days it might not be possible due to COVID, but still try to have Zoom meetings, Microsoft chats, or whatever that is suiting for you. So with that, I would like to thank you very much for your participation in this talk. And if you have questions, I'm all about, I'm very much thrilled to answer them. And I'll upload this to my website after the talk, and then probably we'll send a link to Tamara, where he would be able to send you a link because he has your emails. And therefore, last but not least, I would like to wish you all the best for your future endeavors. I hope you got something out of this. I really hope your wishes and dreams would come true, and that you can make a significant contribution to whatever the field that you would be going on in the future.